Hi, I'm Allison, and I'm currently on the lab site of the Tahoe Science Center, and I want to tell you a story about a species that was accidentally introduced into Lake Tahoe, the Asian clams. So, what does that mean, accidentally introduced? Does it mean that I was maybe carrying a bucket of clams, tripped, and one rolled out and fell into a storm drain and ended up into Lake Tahoe? Probably not. The common theory is that it was a stowaway on a boat and transferred from one water body into another, and that's how we ended up with Asian clams into Lake Tahoe. In 2002, researchers from the University of Nevada, Reno first spotted these clams in a density of about 3 to 20 per square meter, so about the population that you can see here on this black rubber mat. But then by 2008, UC Davis researchers were observing populations in densities of about 6,000 clams per square meters. And these clams are filter feeders. So what they excrete is really high in nitrates and phosphates. So who benefits in our water body from nitrates and phosphates but algae? And so you can actually tell where there were huge densities or large densities of Asian clams just by the sheer amount of bright green filamentous algae that was growing right above their clam beds. So UC Davis designed an experiment to address the threats from this invasion of Asian clams. And it was a fairly straightforward experiment. We took this rubber mat used in the Asian clam bear project, and we used them in about 10 by 100 feet, and we rolled these mats out and targeted specific clam beds in Marla Bay and Lakeside in South Lake Tahoe. So basically, there's nothing really special about this black mat other than the fact that it's impervious. It doesn't allow for the transfer or the flow of oxygen or sunlight. So what we were basically doing was targeting specific clam beds and suffocating them. This experiment had a 98% success rate in Marla Bay and Lakeside in South Lake Tahoe. And we used the same experimental design in Emerald Bay, only we weren't getting the same results. Any idea what's different about Emerald Bay? So initially, we thought it had to do with boats. We actually set up a time-lapse camera at the mouth of Emerald Bay and recorded approximately 1,000 boats entering and exiting the bay on a daily basis between Memorial Day and Labor Day. It turns out after we were measuring the velocity of the water above the mats in comparison with boat wake action that it wasn't actually the case. What it was Emerald Bay itself. So Emerald Bay gets its name from its dark green color. It's green rather than blue because it isn't as deep as the majority of Lake Tahoe. Emerald Bay, in fact, at its mouth is separated from the rest of the lake by a geologic sill. Think of this geologic sill as a sandbar at the beach. Is that sandbar permeable? Can water flow through that sandbar? Turns out that highly oxygenated water from the lake would also travel through Emerald Bay through this permeable sill and allow oxygenated water to enter the mats from below. So what do we do now? So now we're looking at this situation very holistically. It's not just about the chemistry, it's not just about the biology or the physics, it's also about the geology of what's happening. So what can we do to alter our experiment just enough to get to that desired level of dissolved oxygen? So we have our Asian clam mats, and what we did was we added a layer of plant detritus, essentially decaying, dying plant matter. So that way, during the decomposition process, this plant matter is also removing oxygen and producing CO2 instead underneath the mats. And sure enough, we get to that desired level of dissolved oxygen, and all it took was an added layer in Emerald Bay. So this experimental design is actually still being used by agencies in the basin in order to manage the Asian clam populations. Okay, so seemingly a happy ending for what could have potentially been an ecological tragedy. But I've talked about nitrates and phosphates, but I haven't talked about another part of water chemistry, which is calcium. So these shells essentially are just calcium bicarbonate. And once they die, that's when we start seeing them on the surface, and the shells start to break down and leach calcium back into the water. And this calcium-enriched water creates a very suitable habitat for other invasive species. So Asian clams are an invasive species that we are currently managing, but they aren't nearly as bad as what could potentially be introduced. So Asian clams are out of sight, out of mind. They burrow, so we don't see them until they're dead on the surface. However, we have this other species called the quagga mussel that we currently do not have in the Tahoe Basin. I don't know if you'll be able to see them, okay? That we currently don't have in the Tahoe Basin, and we're trying to prevent them from entering the Tahoe Basin. Because while Asian clams are bad, quagga mussels are so much worse because they like to attach themselves onto hard surfaces. And so I don't know if you can tell what this is, but this is actually a propeller from a boat. And you can see that it's absolutely covered in quagga mussels. So if we had quagga mussels in the Tahoe Basin, you can pretty much say goodbye to walking barefoot on the beach. No more rock hopping on our pristine granitic rocks. All of that would be gone. So as a result as a proactive measure to try to keep quagga mussels out of the basin, we have mandatory boat inspections at Lake Tahoe. And the mandatory boat inspection started in 2009. And all motorized watercraft has to be inspected before going into Lake Tahoe, unless you're a Tahoe specific boat. But even then, even with your non-motorized watercraft, you still run the risk of introducing something like quagga mussels into Lake Tahoe. So it's always a good practice to clean, drain, and dry your watercraft, no matter where you're coming from. So it seems like our Asian clam story has come to an end, but it didn't quite end there. Recent studies showed that clams were being distributed around Tahoe, and we finally figured out it was because of specifically wake boats. If anybody is familiar with wake surfing or wakeboarding, you know that you take your boat and you fill your ballast tank with somewhere around 500 to 600 gallons of water, so that way your boat rests in the water and creates like that nice wave that you can surf in Lake Tahoe, which is great, except if you're filling up your ballast tank someplace in the near shore, you have the ability to pull in baby clams, villagers, into your ballast tank, and then you have your fun, go and you dump it somewhere else. You've now just introduced Asian clams to another part of Lake Tahoe. And there's a really easy solution, a couple potentially really easy solutions for dealing with something like this. One, fill up your ballast tank about a mile away from the shoreline. That way you're ensuring that you're getting cold water that's less likely to contain villagers. And then when you dump your ballast tank, try to do it at least a mile offshore as well, so that if you have picked up any of these baby clam villagers, you'll be dropping them off so that they sink to the cold depths of Lake Tahoe, where they'll be less likely to reproduce. So all of these things, from boat inspections to checking your kayak or paddleboard to filling your ballast tank a mile away from the shoreline, all of it seems like small actions, but it's all these small actions that we're all really capable of doing, and it's one personal contribution to conservation efforts here at Lake Tahoe in order to maintain the beautiful environment that we all appreciate so much. So thank you so much for joining me on our Asian clam journey, and make sure you clean, drain, and dry your watercraft. Bye!